All right, Andy, let's go ahead and get started. I'll give you a little front end to this. Good morning, everybody. My name is Chris Modrich. I'm one of the product specialists at Lesman. I'd like to thank you all for taking time out of your busy schedules to join us this morning for our presentation, Best Practices in Mechanical Level Switch Applications. So in this session, Andy Teske, who is an application engineer for the Jurgensen brand under Clark Reliance, we'll be focusing on reliable, robust, flexible, and often overlooked buoyancy technology based level switches to improve your process. Please keep in mind as he's going through this that these devices are basically have built-in logic. They are self-logic solving and do not need to be attached to a PLC or a DCS, which can be very, very handy for your control scheme. During this approximately 45-minute webinar, depending on how many questions we have, Andy will cover when to use a float versus displacer, common applications and markets for buoyancy-based instrumentation, typical mounting methodologies, tips and best practices for applications and installations, and unique applications where these things really shine. So at the end, we'll give an opportunity to ask any questions. Meanwhile, if you have a question along the way, just shoot it into the questions tab and I'll find a spot to sneak it in. So Andy, with all that said, have at it, it's all yours.
Great, Chris. Thank you very much. Started here. Just a real brief history of Clark Reliance. I won't go through this whole thing. In 1884, Reliance Gauge Column Company was founded. In 1908, Clark Manufacturing was founded. In 1963, they were merged to form Clark Reliance. And in 1999, Clark Reliance purchased Magnasonics, which has now been rebranded as Jurgensen level switches. But the Magnasonics brand is where we get the float and displacer level switches that we're talking about today. So I just wanted to include this just so you could kind of see some of the history. Clark Reliance itself, this is our main headquarters of manufacturing in Strongsville, Ohio. This is where we make the level switches. We have our filtration manufacturing, also in Strongsville. This building here on the left is right across the street from the building there. I don't know why we didn't just put them in the same picture. We also have, our OFS facility in Bernie, Texas, and Enervac in Cambridge, Ontario. These two companies make vacuum dehydrators, fuel oil cleaners, transformer oil cleaners, things like that. Just a real brief, I guess, overview of the Clark Reliance offering. My name is Andy Teske. I've been with Clark Reliance for 12 years as an applications engineer and a product sales specialist. All 12 years with the Jurgensen level switch product line. Jurgensen is the only thing I know about. Don't ask me about Reliance or Jacoby Tarbox. But Jurgensen glass gauges, magnetic gauges, and level switches, that is what I do every single day. A real quick agenda, what I'm going to talk about, getting level switch basics, floats, displacers, the Sure test, and some reliability things that we specifically offer Clark Reliance. Okay, common applications for these switches. They're everywhere in industry. Our big industries are oil refineries, petrochemical processing, chemical processing, power generation. These switches are everywhere. They've been around for a very long time. There are thousands and thousands and thousands of them out there right now everywhere. If I know we have customers on this webinar, you definitely have these in your facility. They are everywhere. A little bit of history on float and displacer switches. Float operated switches were one of the first types of switches developed for the industry. They're designed for industrial applications, so pressures and temperatures are higher. With any float device, the limitation is always going to be specific gravity and pressure. The lower the specific gravity, the lighter the float has to be. The higher the pressure, the stronger the float has to be. It's difficult to make things both light and strong. So then displacers were designed. I'll talk about the differences between floats and displacers in a little bit, but the displacer type switches were designed to handle a wider range of specific gravities and pressures. Displacers typically can handle much higher pressures than floats. However, displacers have a temperature limitation. There's always a trade-off here, and we're going to talk a lot about that today. So the first thing I'm going to talk about is top mount level switches. I guess I should back up. There are two main ways to mount these switches. There's top mount and then there's external cage. Top mount is exactly what it sounds like. This is a flange. You would mount it right to the nozzle at the top of a tank. The float or the displacer drops into the tank and interacts with your process that way. An external cage is a separate chamber, usually mounted to the side of the tank. I got some more pictures coming up later, you'll see that. But basically how these work is as your liquid level rises, the buoyancy of that fluid acts on the float or the displacer and causes a magnet inside of this pressure tube to move up or down, and that actuates your switch. It's sort of both as simple and more difficult than it sounds. This one on the right here is a float switch. The float floats in the fluid. This is a rigid float rod connected to a magnet. The float here and the magnet at the top move 1-to-1. If this float moves up 3 inches, this magnet moves up 3 inches. This one on the left is a displacer. It's a little bit different. Where the float floats, the displacer sinks. If you think about it this way, when this unit is empty, when there's no liquid present, the maximum weight of the whole weight of this displacer is pulling on a spring. It's hard to tell if this is a spring, take my word for it. So the whole weight of the displacer is pulling on the spring. So the spring is at its maximum extension, the longest the spring will ever get. As the liquid level rises, the buoyancy of the fluid pushes up on the displacer, causing that spring to retract or recoil, whatever word you want to use. And the movement of that spring, or the deflection of that spring, is translated into a movement up here in the pressure tube mechanism for the switch. So where the float, on a float switch, the float and the magnet move 1-to-1. That is not the case on a displacer. The displacer moves a lot more than the switch. I'll talk more about that, why that matters later, but those are the two main differences between floats or that's the main difference between a float and a displacer. Does that make sense to everybody? If not, please, I don't know if you can shout out your answer or type in your question. Let me know and I can talk about that. I know that can be a difficult concept. I think everyone's familiar with how floats work. If you haven't seen a lot of displacer switches, that may not make sense to you right away. But I'll keep talking about it as we go on through the presentation. But again, let me know if you have questions. So that was top mount. This is external cage. Again, it's the same idea, the same enclosure at the top, the same switch, the same floater displacer. We just build a cage around it. Mainly cages are used depending on mounting options. If the customer if you have side process connections, or if you have existing piping, we can fabricate a chamber to mount that. There's no different function in the switch if it's top mount or external cage. It's the exact same switch. Everything happens the same way. It's just how the float interacts with the process. Most commonly, chambers are carbon steel and stainless steel. We can do, for really high pressure and temperature applications, we see a lot of chromolys. I personally haven't seen very many, maybe a handful of exotic, nickel alloys, Hafstalays, and canals, things like that for the chamber. We can do them if you need it. It's not super common. Flanged and sealed, I'll talk about that in a second. The chambers are designed in accordance with B31.1 and B31.3, very common in our industry. We have our code qualified welders. We fabricate these chambers the same quality as we do everything else we make. So here's the sealed cage and the flanged cage. If you want to think about the flange cage, you take a standard top mount unit and build a cage around it. The flange connection is great because it allows you to, if you need to get in here, if you need to replace a float or clean out that chamber or inspect it, it's removable. It's easier for cleaning and repair, and you can extend the life that way. The sealed unit, on the other hand, it's all welded construction. We put the float in first, then we weld it. So the float is trapped in that cage. Obviously, that means you can't get in there and repair it. You can't remove it. But the sealed design is lower cost. You save on a set of flanges. There's no gasket there. There's no bolting, things like that. It weighs less. When you would choose one or the other is really At your discretion, what your opinion is, what you intend to do with it. We wouldn't tell you, oh, you should definitely go flanged or definitely go sealed. That's really a preference call. A little bit more on the switch mechanism. Jurgensen specifically, we use this tri-magnet design. There are still, to this day, there are a lot of mercury switches in the industry, installed in different locations. There are no manufacturers that currently sell mercury. You know, I don't even think it's legal at this point, but nobody's currently making mercury switches. We just know there's a huge install base. And other competitors are providing micro switches, and those have their own issues. They have at high temperatures, micro switches, you know, the springs can fail and things like that. We'll talk a little bit more about that later. But the Jurgensen design got this nice little video. There's no sound here, so I'm going to talk over it. The magnet on the right is the primary magnet that's inside of your float switch. That's this one. Obviously, that's going up and down with your fluid. And the secondary magnet and the tertiary magnet are both inside the switch. So it's magnetic forces. The magnet inside the primary magnet actuates the secondary magnet, which actuates the tertiary magnet. And the benefit there is it's extremely vibration resistant. You can't shake this thing into its other position. Everything is held in place by magnetic forces. That makes it very dependable, again, vibration resistant. And because there aren't any springs in there, there's nothing that can wear out at high temperature. And this slide just shows the switch offering. We have single pole, double throw, and double pole, double throw, common in the industry. The D4, these letters don't mean anything to anybody, but we have a standard switch, we have a hermetically sealed switch, a high temperature switch, and gold contacts. Depending on what you're using the switch for, you can tell us what you need, you know, what switch ratings, and we'll pick the right one. That's fine. This slide, I included this one essentially for this bottom part of the table. Depending on how we set up the unit, you know, with temperature extension and cooling fins and things like that, we can get temperatures up to 1,000 degrees F. There aren't very many applications for level switches above 1,000 F. Again, I want to keep hammering you on temperature. Our switches, we can do up to 1,000 F because we don't have springs in them. We talked about top mount. Well, we're going to talk about top mount in a second, but I said there's top mount and external cage. The advantages of an external cage float switch: dependable, economical, universally accepted, high temperature limits, everything I've been talking about. These switches are everywhere. Again, there are thousands of these out there. The biggest disadvantage with a float switch, again, is the float. It's hard to make a very strong, very light float. For those really high pressure applications, we do have our horizontal cage float switch. We say here up to 3,000 psi at 700 F. That's actually not even the upper limit anymore. I have an application right now for a customer that's 3,000 psi at 770 F. Obviously, that's a chromoly chamber, so we can get into these really extreme applications. The reason why the horizontal switch works in these higher pressure applications is because the action is sort of reversed. It's difficult to tell, but there's a little pivot point right here in the middle. So as your liquid goes up, your float goes up, and it pulls like a teeter-totter. It pulls the back half down until your magnet moves down to flip the switch. The benefit of this design is we can make this float much stronger. We can make it much heavier, and then we can use counterweights on the other side to still get that action with your liquid. So that allows us to get to much higher pressures if you have those applications. A top mount float switch, it has the exact same advantages of the external cage float switch because it's the exact same thing. It just doesn't have a cage, and it has the exact same disadvantage. I guess I would add here to a disadvantage, because the float has a rigid rod in between, or this unit has a rigid rod in between the float and the switch. You have to think about the length of this rod. you wouldn't top mount this on a 25-foot tall tank if you wanted your switch point, at the bottom 1 foot. You wouldn't want that really long float rod. That's a big mechanism. That rod's going to weigh so much, you're not going to get a float that floats. At longer lengths, nobody's really using a top mount float switch. So I guess just keep that in mind. But here's a great example of a top mount float switch. I think we say in here, yeah. So this is an open sump. You can see there's not even a flange here. I know we've been showing them with flanges. This is a real inexpensive solution, right? When the level in their sump gets up to the float, it's going to switch the switch. Otherwise, it just sits there. There's no pressure here, right? Atmospheric pressure, ambient temperature. This is a real easy application for a float switch. External cage displacer switches. It's the same type of chamber. It's just a displacer instead of a float. Displacers give us higher pressure ratings because they could sink, they could be heavier. You get low cost for a high pressure application. The disadvantage, the spring is temperature sensitive. At about 400 F, depending on the springs start to relax. So if you remember earlier how I described how this works, when this unit is empty, the spring is at full extension. And then as your liquid level comes up, the buoyancy pushes up on the displacer, which causes that spring to contract. If it's too hot, that spring just stays relaxed and you don't get, the switch doesn't function the way that it's supposed to. That's why temperature is a big deal with springs. And that's what limits the upper temperature rating of any displacer and in fact any micro switch, anything that has a spring in it. The other disadvantage, we haven't talked about that, wide switching differential can be a disadvantage. I'll talk in a second about what that means. So hold tight on that. Again, a top mount displacer switch, it's the same as an external cage, there's just no cage. Now you'll notice here I put the wide differential as an advantage, and I'll explain that. The top mount displacer switch is field adjustable. The way that this ships is this is just a 10-foot long cable, and you can put this displacer anywhere you want it. You set the displacer where you want the switch point to be. You can move it at any time. You can coil that cable up. You can cut it, throw it away, whatever you want to do with it. It's extremely adjustable. If you think about a float switch, that rod is whatever length it is when we make it. It's not adjustable. Displacers are. Again, the disadvantage, temperature sensitive. So now I'll explain what these differentials mean. So this top application, single switch narrow differential. Obviously, single switch means there's just one switch in the housing. What the narrow differential means is essentially the switch points, the on and off point, if you will, are very close to each other. On a float switch, there is no switch differential, right? It switches at one point. Wherever you set that switch point, that's where it switches. Up or down, it switches at the same point. Because a displacer does not move one-to-one with the fluid, you have a switch differential, right? If you picture the level coming up, it has to get to here before this moves enough to switch the switch. Similarly, the level has to come all the way down to here to switch that switch back. I hope that makes sense to everyone. I hope I'm doing a good job explaining that. So the benefit there in the top mount is typically when you get to longer ranges. For example, a single switch with a wide differential, right? We can have one switch point way up here at the top, and we can have one switch point way down here at the bottom. So say this is that sump application, right? Hey, when the level gets all the way up to here, we're turning on a pump. I don't want to turn it off right here. I want it to go all the way down here before I turn it off. Right, so you get application benefits with displacers. We can also do these with two switches. You can have two different switch points, right? You can have two switches with a wide differential. It may look a little goofy in this picture just to make it fit on the page, but if you think about it, each one of these displacers could be separated by some amount of cable. Another way to think about it, right, for this two switch wide differential, is when the whole unit is empty, when none of these displacers are covered in fluid, the spring is at its maximum extension. When all of these displacers are covered, when your level is all the way up to here, that spring is at its minimum extension, right? That's your switch range. That's your on and off range of your switch. So you can move these displacers anywhere you want them in the range of your tank. Again, so you have a 25-foot tank. You can move these displacers anywhere you want, and your top switch isn't going to switch until all of the displacers are covered. Your bottom switch isn't going to switch until all of them are uncovered. All right, so if you think about what you're trying to do, not everyone uses two switches. We can go back to this one. You can go a single switch. Hey, this is my switch point. I can move this top displacer up. I can move it down. I can put it anywhere I want it. I can adjust that differential very easily. I don't have to go in here into the enclosure and try and micro move that switch. I can do it physically here. Gives a lot of flexibility, especially in longer ranges. That's the biggest advantage, in my opinion, of a displacer switch, is the adjustability that you get for applications like this. Look, this is a top mount switch. We have 2 switch points. It's still a small enclosure, and we have all this adjustability here. If you think about if this was a float switch and I had 25 feet in between this point and this enclosure would have to be 25 feet tall to accommodate those switch points on a float. But because we have the spring, the way the displacer works, it's a much smaller enclosure, a much smaller envelope. It's one process connection on the top of the tank, and you get all this that you can use. Again, does differential make sense to everybody? If it doesn't, please let me know. We're talking about reliability. I talked about reliability of the tri-magnet switch, and I want to talk about a little bit. It's API 2350. It's a new requirement of a couple of years ago. Displacer switches, especially on floating roof tanks and fixed roof storage tanks, they have to be tested semi-annually unless there's a technical justification. I don't know what the technical justification is, so they have to be tested semi-annually. And how we do that, we call it our sure test. We really like magnets. I know this can be difficult to see, but if you pull down on this handle, you lift this external magnet, which pushes up an internal magnet, which then, as far as the top of the displacer is concerned, mimics the movement of the displacer and causes your switch to switch. You'd radio into the control room, hey, I'm testing tank 11. You pull the handle, the magnets move, you get your switch output. You let go of the handle, a spring resets it. The biggest benefit of our design is it maintains the pressure boundary. These magnets are external. We do put an internal magnet in there, but there's you're not breaching that pressure boundary at any point. Competitors offer a similar design, but theirs breaks the pressure boundary. And again, I told you earlier, there are thousands and thousands and thousands of these switches out there. If they're more than a couple of years old, they don't meet this API standard. So we have an option for that. There should be some retrofits out there. Again, keep that in mind. You want to be able to test your switches to make sure they work. Nobody wants a failure at a tank farm. You can lose a lot of product that way. This is just a picture of one on top of a tank. We can make it with an angle and a pulley, so you can test it from the ground level. And switch upgrades. Again, we know there's a lot of mercury switches out there. We know that micro switches use springs and cams and things, and we know that often they can be applied at high temperature applications where they shouldn't be. We can retrofit those switches. If the chamber is in good shape, if you have a chamber and the chamber is in good shape, if the piping's in good shape, you can just replace the top works. Just the switch mechanism can be replaced. The benefit there, you don't have to cut anything out. There's no welding required. Excuse me, it's very, very common for these switches just to be welded in place. So if the chamber is in good shape, maybe it's difficult to get a hot work permit to cut out a chamber that's in good shape, so just replace the switches. Obviously, if you have mercury in your facility, please get rid of it. It's toxic, it's hazardous, and quite frankly, it's not as reliable. And if you have old micro switches, get rid of those as well. It's a 6-step process to retrofit the switches. And I do have a quick video. I hope this works for everybody. I hope you have your speakers up.
Level switch reliability is critical to plant operation. Oftentimes, a false trip will result in costly unscheduled downtime. So why is it that most level switches are not reliable? Spring failure. Springs can relax when exposed to high temperatures, leading to false trips, with the well-known remedy being to wrap the housing to free the mechanism. Another attempt at a solution is to remove the cover to dissipate heat, which exposes the mechanism to contaminants and exposes glass mercury tubes to breakage. The Jurgensen tri-magnet switch has a unique positive snap action without cams or springs, a design which provides unparalleled reliability. The magnet on the float rod inside the pressure tube drives the secondary magnet, which in turn drives the tertiary magnet, which drives the switch contacts. Each magnet repels the other. The use of repelling magnetic fields creates a positive interlocking switch that is extremely vibration resistant and compensates for installation misalignment. The tri-magnet mechanism is reliable and remains reliable even under severe vibration, a unique benefit of Jurgensen's design. Mercury and spring-operated switches can't handle the vibration and are prone to false trips. The tri-magnet switch has been tested to over 850,000 cycles without a failure. Field upgrades are simple, with no new piping required. If your existing float chambers are sound, you can replace the switch and enclosure without removing the chamber. The whole process takes about 20 minutes per switch. Or you can easily upgrade with a new switch and chamber. Either way, you'll replace the switch just once, instead of frequently with your old switch. And for high pressure applications, our horizontal design will withstand pressures to over 3,000 psi at 750 degrees Fahrenheit. In addition to improving process reliability, the Jurgensen tri-magnet can help improve plant safety. That's because it's completely mercury-free, making it environmentally friendly and removing a hazardous material from your plant. So if level switch reliability means anything to you, it's time to go with Jurgensen, the world's most reliable switch.
Okay, and before I open it up for questions, I don't have a slide for it, but I wanted to, I guess, address what I would call best practices. When you're looking at a switch application like this, whether it's top mount or external cage, the most important thing to consider are the design conditions. A lot of times instrumentation is concerned with operating conditions. The way that these switches are typically used, we are very concerned with the design conditions. As you can see in this switch being held here, this is a socket weld connection, and this is a sealed unit. So this switch isn't removable, the float's not removable. So this is going to be welded in place and it's just going to be there permanently. So if we know the design conditions, that is the best way to pick the appropriate unit, right? We've talked a lot about temperature. If we know it's if you know there's a high design temperature, that's going to rule out a displacer right away. But if you give us the design pressure and the design temperature, along with the specific gravity, we can pick a float that's always going to work. The worst thing you want to do is weld one of these into place, find out that the float was only designed to the operating conditions, you know, if you have an upset condition and the float fails, then you got to cut that thing out. If you design the float, excuse me, for the design conditions, or if you're going to hydro test the unit or something like that, we can design a stronger float in there, and that way it doesn't fail and you don't have to cut it out. I'd say that's the best practice. The benefit to the design is the switches. You know, I can replace other people's switches. I can also replace my switches. If you had, let's say you had a 10 amp switch in there and you were directly switching a pump, and now you want to run that switch output to a DCS instead, you can switch the mechanism out, put in gold-plated contacts, a lower current. You know, we can retrofit switches that way. Replacing the top bits are easy. Getting inside the chamber may not be, especially if it's a sealed unit like this. So I just wanted to mention that the design conditions is probably the most important information when determining which one of these to use. And with that, I'll open it up for questions. Yep, sorry.
Andy, question is Chris. So can you speak to the tolerance of the two different devices, a float versus a displacer, as it relates to coating, fouling, particulates?
Well, yeah, there are. I think I understand your question, so I'm going to answer it. Let me know if I'm way off base here. There is no. I'll go up and show you a picture here. On either the float or the displacer, there is no magnet in here. It can be a common issue with a magnetic gauge, where you can get magnetic filings and things like that adhering to the float because there's a magnet inside the float. There is no magnet here. So the only buildup you're going to get on the float or the displacer is something it's going to build up on the piping. It's going to build up on the cage if you have it. It's going to build up on the tank walls. And if that's the application somebody has, they should absolutely have a cleaning procedure, a scheduled maintenance to clean all of those things. The floats are 316 stainless steel. The displacers are 316 stainless steel or brass. Brass is typically used for the floating roof tanks and things like that. But there aren't any additional concerns about things. You know, you're typically not going to use these in things like a sludge. You know, it has to be a liquid. It has to have a specific gravity. You know, it has to flow a little bit. So build up on the float or the displacer isn't any more of a concern than it is on any of the other piping components related to it. Does that answer your question?
It does. Now, so if you have buildup on a float, it's going to affect the buoyancy. If you have buildup on a displacer, it's going to be a little more forgiving. Is that correct?
Yes. Yeah. Just the nature of a displacer kind of sinks a little bit. If somebody has an application where they're concerned with that they would get enough buildup on the float or the displacer to cause issues, that's a conversation we want to have ahead of time. And I guess it also depends on what the specific gravity is of the fluid in the first place. If it's, you know, if you have water at 70 degrees F, you know, that's a 1.0 specific gravity. That's a little bit more forgiving than, you know, you have a lead and hydrocarbon at 0.6. You know, it's other aspects of the application may make us more or less concerned about having a floating device in there. But yes, typically because of the way that they work, a displacer could be more forgiving in that case.
Okay. I'm going to go ahead and unmute the audience. If anybody has any questions, you want to jump in, you're welcome. We'll give you a minute. Well, last chance for questions, if you will. Andy, nice job. Appreciate it. So for the attendees today, if you have any specific application questions, please feel to give us a call at 800-9-LESMAN. If you don't know your account manager, ask for me. Again, it's Chris Modrich, Modrich. You can get me at chrism@lesman.com. We do a lot of these webinars. We post them all up on our YouTube channel and encourage you to go there and look around for things you might be interested in. If any of you that have attended today have any suggestions on different topics you'd like us to cover, we always think it's a good idea to take our customers to school and teach them new things and expand their horizons and just help them solve problems. So at this point, if there are no more questions, I don't have any written questions. We're going to call this the end of the webinar. So thanks, everybody. Have a good day. We appreciate your time today. And thanks again, Andy.
Sure. Thank you.